Good day, everyone. I want to welcome you to another statistical class. But before I get started today, I got some series of announcements and I need you to pay attention. I'm also going to put that on the canvas as well. So, number one announcement is that the other time I mentioned that those who are not satisfied with their score who actually discovered the scores they got in midterm one is far from expectation because I asked them to reach out to me. They've already done that. And this is what I've decided, what I'm going to do. Sometime next week, I'm actually um, going to, uh, set makeup questions. And the makeup question for exam one will be shared on Canvas. It's actually going to be on the coin section of Canvas. It's going to be programmed for 90 minutes. The moment if you are not ready to start, don't start. If you click on start, your time is going to be running out. So they're all going to be multiple choice. Um, if you are satisfied with your score, you don't need to attempt this question. You don't need to open it at all. So it's just a midterm one makeup for those who want to improve on their grade. And let me just tell you the deal. In order to be fair to students who perform excellently in the midterm one, what I'm going to do, whatever you score in the makeup, I will multiply it by 0.7. Then I will multiply your previous score by 0.3. Then I'm going to add them up. Does that make sense? So, which means the new makeup is going to have a 70% weight. The old makeup, we have a 30% weight. So there's going to be an instruction tomorrow, announcement about that when the exam will be uploaded. Okay. Like I said, the exam is going to be uploaded next week because I know it's a Thanksgiving week. So you're going to have time, for those who really want to improve on their grade. If you're not interested because everyone will receive the notification. If you are not interested, like improving your grade, don't open the exam. Because the moment you open the exam, the time is going to be running out. Immediately you submit the exam, you're going to receive your grade because it's automatically programmed. Okay. And whatever grade you get, that grade is not your final grade. I'm going to multiply the grade by 0.7. I'm going to multiply the one you had before by 0.3. Then I'm going to add them up. It's going to be your new grade. Okay. Another announcement. I've actually told my TAs next week lab session. Uh, there's not going to be in-person lab session next week, being the week of Thanksgiving. I've asked them to record their lectures. They're actually going to record the lab sessions, okay? But they record that, they're going to share with the students the recording, okay? So I think that's what I've asked them to do. And there's not going to be assignment next week, okay? Now, after today's lecture, we're going to have in-person class on Monday, but the lecture on Wednesday will be on Zoom because I know Thursday is Thanksgiving. I'm going to say that again. Okay, Monday, I'm going to be here in person. On Wednesday, okay, we're not going to be here. You need to join Zoom for lecture for Wednesday. And finally, there is no class on Friday. Finally, there is no class on Friday. I want to welcome you to another statistical class. This topic is called Follow-up to the Analysis of Variance F-test. Of course, before now, I introduce you to analysis of variance. Of course, we normally use analysis of variance when the number of groups or the numbers of populations we're comparing is actually more than two. Of course, I show you, give information about that on Monday. I also gave another information on Wednesday. But today, uh, we're actually coming to this title because we've conducted analysis of variance tests and the null hypothesis has been rejected. When the null hypothesis is rejected, the analysis of variance cannot tell us where the difference lies. And that is why we need a follow-up. We actually want to know where the difference lies. Okay, this is a follow-up. So in the outline, I'm going to walk you through multiple comparison tests because the follow-up to analysis of variance tests requires that we should have a pairwise comparison, okay, test. And that very test is also called, okay, it's also called post hoc test. We call it post hoc test. So why is it called post hoc test? It's called post hoc test because it's a test that we normally conduct after the null hypothesis has been rejected in ANOVA. If we fail to reject the null hypothesis in ANOVA, we do not need this follow-up. Okay, I need you to pay attention. Now, I need you to be focused. 100% chance this is going to be on the exam, final. Okay, chapter 14 is 100%. If you check announcements, I mean the module, I've already shared final exam practice question with solution. You're actually going to see question from analysis of variance and order now. Now, I need you to pay attention now. Okay, I need you to pay attention now. I presented to you on Monday example where we want to compare 3 groups of therapy. The first group, okay, is cognitive behavioral therapy. The second group is called family therapy. The third group, no therapy, making 3 groups. What do we want to compare in these 3 groups? We want to compare gaining weight, okay, of at least 72 teenage girls. Now, the data said so that, of course, if you copy this into R, you're actually going to have access to the data set. Okay. Now, in the data set, we got some variable like change, that is change in weight, because the teenage girls, their weight were measured before being subjected to a particular therapy level. And after being subjected to therapy level, we also measure their weight. So the difference between the new weight and the old weight is okay, what we call change. I'm going to say that again. Before we subjected them to therapy, we measure their weight. After being subjected to therapy, we also measure their weight. Now we look at the difference between the weights. Okay, the difference between the weight may be gain, maybe negative or positive. Okay, so we're interested in change. The response variable is change. Okay, now the independent variable is therapy, because therapy is categorical variable. If I want to run analysis of variance, the moment I have my data in, this is the code. It's going to be AOV1 less than minus AOV. AOV means analysis of variance. AOV means analysis of variance. Now, the very first thing you're going to see in the parentheses is the response, what you are comparing, which is the change in weight. That is what you are comparing. Then that will be followed by therapy. That therapy is a categorical factor that you are looking at the effect. The categorical factor therapy has 3 levels. Okay, 3 levels. 1, cognitive behavior therapy. 2, family therapy. 3, no therapy. Now let me tell you this. R, R will automatically generate an output which is going to be this. Do you remember on Wednesday, getting an ANOVA table is so tedious? We have to go from one cell to the other, and they are all connected. But with a simple code of R, okay, now how do we automatically generate the F statistic value? The F statistic value is 5.4223. How do we automatically generate all of that? In addition, how do we generate the p-value? Automatically. You can see the role of computer now in the scientific world, in the research world, because software we had the computation within 1 second. You're actually going to have your ANOVA table with the p-value that come with the table. Now, as you can see now, if you take a look at the p-value now, right? The p-value in the output, okay, the p-value in the output is less than the 0.05 level of significance. And therefore, we're going to reject H naught. What is H naught? The H naught is that they have the same weight gaining, the response is the same. The weight gain is the same across levels of therapy. Why the alternative is at least two are different. So right now, because of the fact that p-value is less than 0.05, we reject H naught. But let me tell you this. Here, we don't know where the difference lies. We don't know whether the difference is between family therapy and cognitive therapy, or the difference is between cognitive therapy and no therapy, or it is between family therapy and the other one. We don't know from here. The only thing we know from analysis of variance tests is that it's either we reject H naught or we fail to reject H naught. Now that we're rejecting H naught, we want to know where the difference lies. And that was why I said this. I said a follow-up to the analysis of variance. I said when we reject the one-way ANOVA F test for equal means, we can only conclude that at least two of the groups means are significantly different than each other. Okay. However, we cannot use this test to determine which means are different or how much they differ. In this case, we should perform a further analysis. And that further analysis is what we call a follow-up to the ANOVA test, that we also call a post-hoc test. Does that make sense to everyone now? You can see statistics is like a story that goes on and on and on. Now, that is now going to take us here. And I will need you to pay attention. You know, what we were trying to investigate before is that guy, right? H naught, mu1 equal to mu2 equal to mu3. HA, at least two means are not the same. We've rejected this H naught. And rejecting this H naught right now, we now want to look at want to have a pairwise comparison test. Okay. But let me tell you this. I told you on Monday the reason why we cannot use the method of chapter 10. Okay, because when we use a method of chapter 10, when the number of tests increases, the type 1 error will be exceeded. I think I show you that on Monday. Okay, but we find ourselves now there, okay, where we want to have a comparison test. But let me tell you what we're actually going to do. We are not going to apply chapter 10 approach exactly. There will be some adjustments. I need you to pay attention now. There's a lot of multiple choice question that I'm just dictating out right now. You know, when you are in my class for lecture, if you can listen attentively, a lot of multiple choice, what could be answers to some multiple choice questions. They are in what I've been saying. I said something right now. We want to do follow up to analysis of variance. We have rejected H naught. But we want to compare them pairwise. Look at that. Pairwise. Mu1 minus mu2 means I want to look at the difference. I'm trying to say, oh, difference exists. Does a difference exist between the first two groups? That's why I say the mean of the first and the mean of the second. Does it does a difference exist in the first group and the third group? Or does the difference lies in the mu2 and the mu3? Okay. Now, I now want to use, please listen. Listen. I see some people discussing. I'm begging you to listen for you to be able to get what I'm saying right now. It's very, very crucial. Now, I want to know where the difference lies. There's possibility that difference may not be here, may not be here, difference may be here. At least difference will be in one of them. Because we have rejected this not. Difference exists. But we want to know where the difference lies. I'm still coming here. Let me give you another example. Let's say, for instance, you want to compare the standard of living. Maybe you want to compare average household income in the state in the Midwest, in the United States. Minnesota, Wisconsin, Michigan, Illinois. Let me just say those four states, for instance. I got four populations. Let's say after running the ANOVA test, we rejected H naught. Now, if we have rejected H naught, we want to do a follow-up, we want to know where the difference lies. The question is going to be, is it different that exists? Does it lie between Minnesota and Wisconsin? Or Minnesota and Michigan? Or Michigan and Illinois? That's what we mean by POS comparison. But when we have a POS comparison, it's now looking like what we did in chapter 10. But I said we are not going to apply chapter 10 exactly. We need to adjust for the T-score. And when we adjust for the T-score, okay, the method that we're actually going to be using, we call that Turkey Honest Significant Difference Test, that we also call Turkey HSD. Okay, Turkey enabled us, Turkey was able to justify, I'm sorry, it was able to, you know, adjust, the T-score in chapter 10 in such a way that the type 1 error will not be exceeded. Okay, and how they did it, how did he do it? I'm actually going to tell you right now. Okay, when he adjusted the T-score, okay, the distribution is no longer T distribution. I'm going to say that again. In chapter 10, well, can you all hear me, right? In chapter 10, when we're comparing two groups of means, we're using T distribution, right? T-test, right? But Turkey adjusted that to, instead of using a T distribution, he used studentized. Please write it down. Studentized. He used studentized range distribution. Studentized. Studentized range distribution. Range distribution. Instead of T distribution. Okay? Instead of T distribution. Because what we did in chapter 10 actually used T distribution. But Turkey adjusted that to studentized range distribution. With studentized range distribution, then you'll be able to control type 1 error. Let me tell you this. There are other alternative approaches, because when you search literature, you're actually going to see so many ways of achieving this. Turkey is one of them. We have Bonferroni. Okay, so but the common one in literature is Turkey. That's why we want to use Turkey now. Okay, let me tell you this. The reason why we're choosing Turkey because Turkey is conservative. Bonferroni is liberal. What do I mean by conservative? Conservative in the sense that it will enable us to maintain type 1 error, even reduce type 1 error. But the problem, the problem with Turkey? It may lead to increase in type 2 error. But we're not interested in that. Our intention here is to reduce type 1 error. Okay? Now, let me tell you this. Turkey, using the Turkey approach, actually going to construct simultaneous confidence interval for the pairwise comparison. I'm going to show you the code now. Okay, take a look at this. Now, this is the data set again, right? That is the code for the data set. Then this is the code. This is the code for the ANOVA that we did the other time in such a way that when you do the summary of AOV1, you have the output and you're able to know that, you reject. Now, let me now show you the Turkey code. Please pay attention. Take a look at this. Give me 1 second. Take a look at this. Do you see that? Turkey HSD AOV1, because this is a follow-up. AOV1, you're going to indicate therapy, because therapy is a categorical factor with 3 levels that we're comparing. Then under the confidence level, you're going to put 0.95. Why am I putting 0.95? When the level of significance of your ANOVA test is 0.05, which is 5%, then the level of confidence is going to be 95%. Okay? Now, when you do that, you know what the output is going to be? This is the output. I need you to pay attention now. R has automatically computed confidence interval and the p-values. And I need you now to look at the board. I'm actually going to explain one after the other. Now, in the output, let's start with this. What is that? What are we comparing? Control with cognitive, right? I told you we're going to compare them on a pairwise basis. Pairwise. Don't forget we got 3 groups. The possible numbers of pairs is going to be 3. When you have 4 groups, the possible numbers of pairs will be 6. I gave you a formula. Was it on Monday? G into G minus 1 divided by 2. Yeah. Does that make sense? Now, pay attention. This is on the final. Pay attention. I want it to pass excellently. Final has a huge weight. I want all eyes on the board. Now, what is this? You know what this guy is saying in the output? Now, take a look at this. I'm talking about the difference between this now, and let's see this. When I do control minus cognitive, you know what this is telling me? The difference between the mean of response for those with control, no therapy, and cognitive is negative 3.45687. When you have a negative, you know what I mean? The weight gain with the cognitive is greater than control, right? If I have 2 minus 5 and I have minus 3, it means the second number is bigger than the first. But we don't know whether this difference is significant. The only way to tell, please focus on the board. The only way to tell whether this is significant is to look at the confidence interval. They say the confidence interval. If the confidence interval is from negative to positive, then 0 is inside. When 0 is inside, there is no difference. There's no significant difference. You can see here, negative 8.327. The L WR is lower, the lower bound. This is the upper bound. When you are from negative to positive, it means the difference that exists is not significant. Therefore, the difference doesn't lie in the control and cognitive. Does that make sense? Now, if I want to use a p-value, let's use a p-value now. Is 0.2124428 is greater than the level of significance of a 0.05. What happened when p-value is greater than level of significance? You fail to reject H naught. Do you know the H naught here? Because you're going to write hypothesis out. Okay, for the first one, you're going to write this. Okay, H naught. Okay, mu1 minus mu2 equal to 0. Alternative mu1 minus mu2 is not equal to 0. Now, take a look at that. What has happened now? We fail to reject H naught. The mu1 is the mean of the control. The mu2 is the mean of the cognitive. Does that make sense? Now, when you take a look at the p-value here, it's greater than level of significance. When you look at the confidence interval, because it's from negative to positive, 0 is in the interval, then you're also going to fail to reject H naught. So which means the difference that exists is not between control and cognitive. I'm going to go to the next one. Now, going to the next one now, I want to talk about family and cognitive. Then I'm going to write hypothesis out again, where I'm going to say H naught, family, the mean of family minus the mean of cognitive equal to 0. Alternative, the mean of family minus cognitive is not equal to 0. Now, let's look at the difference. Now, in this case, the difference is positive, 4.257809. And when the difference is positive, it means family is greater than cognitive, right? That's why you have a positive. But to know whether it is significant or not, let's look at the confidence interval again. What is that? Also from negative to positive. 0 lies in it. Therefore, we're going to say even though difference exists, but it's not statistically significant. Now, if you also want to use a p-value, look at the corresponding p-value. It's also the same. Because the p-value here is greater than 0.05, then you're also going to fail to reject H naught. Now, let's go to the last one. Now, the last one now, we want to look at the family versus control. Okay? Let's look at the difference. The difference is very, very huge, right? 7.714706, because that difference is positive. It means the mean of family is greater than the mean of control. Okay, don't forget, some teenage girls that were given family therapy and some girls that were not given any therapy at all. We compare the mean weight, okay? And we see that. Now, if I want to know whether that difference is statistically significant, then I'm going to look at the interval. Oh my God. When you take a look at this interval now, it is it is not from negative to positive. It is positive to positive. Whenever you have a positive to positive, that's a significant difference. Means significant difference exists. And not only that, okay, even if it is negative to negative, or positive to positive means statistical significant difference. But negative to positive is statistically insignificant. Now, let's take a look at the p-value as well. Oh my God, the p-value also agree, because when you compare this p-value with the level of significance of 0.05, it's less than 0.05, you're actually going to reject H naught. So which means the reason why we rejected H not in ANOVA is because of the fact that the difference that exists is between family and control. Does that make sense to everyone? How do we make a conclusion about this? This is how we made a conclusion. We're going to say the mean weight gain for the family therapy group was significantly higher. Why do I say higher than? Can somebody tell me? Why do I say higher than? Why do I say significantly higher than? Yeah, exactly. Send me a message for extra credit. Is that what you want to say? I can read your mind. Send me a message for extra credit as well. Okay. Oh, somebody also raise up a hand here. Who is the person? Oh, nobody. Okay. Now, when it is positive to positive, if you look at the confidence interval, it was positive to positive, right? If you also look at, if you also look at the difference, what do you see? The difference is positive, and that was why I said family higher. Okay. If it is negative to negative, okay, negative to negative. Let's say, for instance, this guy is significant. I'm just assuming. If this guy, let's say this guy is significant, you would have said that control is lower than cognitive. Does that make sense? Okay, let me tell you this. After saying that, I said higher than control group, all values in the interval are greater than zero. You can say I put my reason. Then I say, however, because I also need to take a conclusion about those ones that are not significant as well. I have to tell the world. I said, however, since zero falls between the lower and the upper value of the other two intervals, which is the first comparison and the second comparison, then the mean weight gain is not significantly different among the control and cognitive. Take a look at that. Among the control and cognitive, and not only that, among the family and cognitive. Even though we identify differences, right? Different exists, but the difference is not statistically significant. That's what we're reporting now. Okay, now I said, okay, different among other control and cognitive behavior group, not among the family and cognitive behavior groups. You can see what we just reported. Different exists. We're told that different exists initially, but we don't know where the difference lies. And because of that, we conducted a post hoc test. And the name of the post hoc, there's so many alternative of post hoc tests in statistical literature. Okay. But in this class, I'm adopting Turkey HSD. Okay. The Turkey HSD still use approach of chapter 10, but adjusted the T-score. Instead of using the T distribution, it uses a studentized range distribution. Now, let me tell you this. In this class, if I show you the mathematics involved about the formula, the studentized rate, it is beyond the scope of this class. So the only thing you just need to know about is that the T distribution is not being used anymore, but what was used is a studentized range distribution. With a studentized range distribution, it was able to control type 1 error rate. Because if you go by chapter 10, if you use the idea of chapter 10 exactly, okay, you will inflate type 1 error rate. In statistical research, in research in general, we don't want to inflate type 1 error rate. And that's why we're actually using, Turkey HSD test. Now, let me tell you what we're going to do next. What we have left, chapter 3 and chapter 11, they can be done in just a week because there are not many. But in